Today we're going to cover chapter 7 of our Programming Logic and Design course, and we're going to talk about input validation. These are our learning objectives, so we're going to cover the concept of garbage in, garbage out. We're going to talk about the input validation loop. We're going to talk about what is defensive programming, and then I'm going to show you some examples in Python. So, the concept of garbage in and garbage out starts from here. So if a program reads bad data as an input, it will produce bad data as an output. There's no other way around it. So, programs should be designed to accept only good data. And what do we call good? Is data that is usable, data that is correct, and data that is valid, a valid form of data. So, whatever we ask the user to enter, they should only be allowed to enter the information that we're asked them to. For example, if we ask the user to type in their password, right, on their keyboard, they shouldn't be able to upload a picture instead of their password, or upload a video instead of their password, right? So this is the example of good input data. Okay, so how do we achieve that? We achieve that through input validation. So what does that mean? Is that all inputs should be inspected before we process them, and then the computer should figure out if the input that was given to us is valid or not. Simply good or bad. If the input is good or if the input is bad. So if our input is invalid, which means bad, it should be rejected, and it should tell the user that your input was bad, give us the new one, give us the good one, basically. So input validation is commonly done with a loop that iterates as long as the input is bad. And what does that mean? We can look at this flowchart right here. So we're going to get our input. Let me click my pen. We're going to click our input. So what we're going to do, we're going to get our input right here. Then we're going to ask a question. Is the input invalid? Is the input bad? If it is bad, we're going to display an error message and ask the user to type the input again. And then we go back to step 1. Get input, check if it's valid. If it's not valid, we're going to display an error message and get the input again. And this can go on forever. So whenever the user types the right input, we're just going to proceed to the rest of our program. There is a thing called priming read, and it's important that you focus on this definition. It is the first input that is going to be tested. So the first thing that the user gives us is called a priming read. It is recommended that if you write a function, if you need to perform a complex validation, that you will write a function. It just makes your code look cleaner, and it just makes your life a little bit easier if it's a really hard validation that you need to do. However, there is such simple validation as string input. For example, some strings we validate with programs that just ask for a specific string input, like yes. Have you ever been on a website that would ask you, if you want to subscribe, type yes in this checkbox or something like that? That's exactly what's happening. They're validating your input. It's either yes or no, nothing else. Or whenever you need to type in your phone number somewhere, right? You're using some kind of app, or you're registering for something and you're typing out your phone number. And if you put some words in there instead of your phone number, it will give you an error. It will say, no, not a valid phone number. Please provide a valid phone number. That's exactly what input validation is. See, or the programs to specify a string to be specific length, like password. For example, have you ever gotten a new account somewhere, and there are all of these validation for password, right? 8 characters minimum, you need to have a number, you need to have a capital letter, you need to have a special character. This is all input validation. So it's going to check if your password has all of those, and if it does, then you're good to go. If it doesn't, it will tell you, oh, you're missing a number, or you're missing a capitalized letter. This is the work of input validation. So defensive programming now. Input validation is defensive programming because you are preparing that the user will make a mistake. you're preparing yourself and your code that the user is going to be in the wrong when they're typing out their input. So, yes, you have to remember that input validation is called defensive programming, is part of defensive programming. And it's practice of anticipating both obvious and unobvious errors that can happen. So basically, you're getting prepared for everything. That's where the name is coming from, the defensive programming. And type of errors that you should consider when you're writing code is if the user just gives an empty input, doesn't type anything, where a user accidentally hits enter before they could type anything, or if the user enters something wrong. And I gave you some examples, like if the user tries to upload an image when you're asking for a word. And here are some just common errors that you need to be aware of. So some state abbreviations should be 2-character strings, right? 2-character only, LA, Louisiana, Texas, TX. And zip codes should be in the proper format of 5 or 9-digit. And you can pick if you want them to use the 5-digit or the 9-digit version of your zip code. That hourly wage and salary amounts should be numbers. And it should be within the range. Because hourly wage, like if someone tries to input $10,000 as an hourly wage, you know that's not right. That dates should be checked. You should check if the date is real. In case someone want to put, if you're signing a document online, that's a very important part. If you're signing a document online and it asks you for the current date, right? Like that's date today, you know, at the bottom it asks you sometimes like input the date of today. And for example, if you would put a different one, or you put the date in the future or the date in the back, that should not be a thing. You should check for that always. Then any time measurements, they should be checked, and you should check if the numbers are reasonable. Same thing as with hourly wages right here. As I told you, an example, if someone puts $10,000 that they get in an hour, you know that's something is not right. Here's a little bit of example with Python, and we have a program that calculates retail prices, and we have our main function right here, the start of our code right here. Then we have a variable to control our loop, and then we have process of adding one or more items. So while another equals y, or another equals capital Y. See, input validation, we're checking if the user types a capital letter or a lowercase letter. Then we would display an item's retail price. And we have do you have another item? Okay. And we have the example right here. Okay, so what the program is going to do, it's going to ask you to enter the item's wholesale cost, and then what you're going to put in there. And see, if we put negative number, because the price cannot be negative, it's going to tell us it's an error. The cost cannot be negative. And this is where we find it. It's right here. Our error is right here. The cost cannot be negative. See, this is the validation loop right here. Validate the wholesale cost. And then enter the correct wholesale cost, 0.5. Then it tells you the retail price is 1.25. Then it asks you, do you have another item? Enter Y for yes. So this code will only start executing again if you type Y, or if you type capital Y. If you type anything else, the code will stop executing. Let's look at this again. See, this is where it comes from. Another equals Y. While another, this is our loop. While another equals Y, or another equals capital Y, display an item's retail price. And then it asks, do you have another item? Enter Y for yes. That's all I had for today. Hope you enjoyed.